Let's go build an MMX. Well, this... All right, let's begin the build. So, what we have here are all the parts laid out. Some of the pieces have been pre-assembled, and I am not going to bore you with things like heat press inserts. I printed everything in ABS. I love ABS. The idlers and the cam are both printed in PETG. It's a nice, shiny, slippery type of material. I pre-built things like the LED strip. I am using the RGB LEDs. Things like the motor cable, shorten the servo cable. I made a little wiring harness, and I'll show you how that gets hooked up in a little bit. That goes from the EBB42 to each of the sensor switches. And so what I did was I just used some JST connectors, and I crimped the ends. And the JST connectors, if you cover them in a little bit of heat shrink, they fit nicely over the pins. And so you put them over the pins like that. That way I didn't have to solder them in place. It makes it a lot easier to troubleshoot afterwards, instead of having soldered wires all over the inside. So we'll talk about that. Two belts. There are two different belts. There's a 184 and a 188. All right, 188 and a 184. I don't know if you can see that or not. 188. Okay. All the bearings, those are all in the bill of material. The two parts of the BMG drive gears, there are the ones that are going to be the actual drive gears, and then the idler gears. There are 5 rods altogether, 2 of the 5mm, 1 of the 3mm. Those go through the idlers, plus 2 threaded rods. Okay. The front portion of on the outside, right, on the exit side of the MMX, these are printed in a translucent ABS, and so what that allows for is the LEDs, when they light up, you can see these change the particular color. Now on mine, I mounted the MMX on the side, and so I just built a little strip that goes in the front of my machine that's labeled with the numbers. So, all right, I am working with the draft version of the document. All right, I'll make that available as a link at the bottom of the video. And everything is nice and neat and organized right now, but it's not going to stay that way. Okay. So I just thought I'd give Nadir and the guys at CN3D a little plug, and I put their logo on the end plate of the MMX. Okay. All right. So all of the heat set inserts are already in place. So let's just talk about some of the assembly that I had to do for particular components. All right. Let's start with these, and I'm going to get a few things out of the way, okay? All right. All right. So on the idlers, 2 things have to happen. One is a magnet is going to have to be installed. It's a 6x3. I'm using the N52s. I know you can use the N35s. The N52s are a little bit stronger, and you put them in a repelling repelling orientation. And I'll show you that. As well as the end here. Now when you print PETG, it's very difficult to print with supports, especially through the center hole of these idlers. So you're going to print without supports. When you're done, you pull it off the plate, you will have to clean up those holes, because one of the things that has to happen is you have to be able to insert loosely some PTFE tubing into the hole, okay? And the PTFE tube is inserted because we're going to need to be able to take that 3mm rod. A 3mm rod is going to be inserted into that PTFE, and this needs to move. This needs to move freely, okay? It needs to move very freely. So if your PTFE is squeezed inside of that hole, it's not going to allow it to move freely on the 3mm rod. Little note while I'm thinking of it. The 5mm rod that we're using for the drive gears is a round rod, okay? Now, I have it running two different ways, and they both work fine. In one of them, I'm like, I don't think I want to use round rod. I want to use D-rod, because I want to be able to effectively use the set screws on the drive gears. I can tell you that they work just fine on the round rod too, okay? So just giving you a heads up on that. All right, so the way that I'm going to do this is I have number 3, which is the last, right? So there's 4 of them starting at 0. 0, 1, 2, 3, all right? And I have a piece of PTFE. PTFE is going to go into that hole, right? It's a little bit snug, probably snugger than I would like it to be. And then I'm just going to take a blade, nice sharp, brand new blade, and I'm just going to cut that even with the edge. Even with the edge. I'm trying to do this on camera, so it's like that and like that. All right. And then we have PTFE is inside. All right. Let me take my 3mm rod, put it through. Actually, that's pretty nice. Okay. Very, very nice. Okay. So that's like the perfect combination. Slightly snug fit of the PTFE, yet it means it's nice and round because this goes through and moves freely. Okay. And then you're going to have a magnet, and I'm going to try and make sure that they're all the same way. So I know that all of my idlers, okay, are in that magnetic polarity. So I'm just going to go ahead and put that in the hole in the same orientation, okay? And with the PTFE, you can actually kind of get it started a little bit like that, and then what I do is I just take a piece of rag, channel locks, just squeeze it into place. I don't like the way that feels. There you go, perfectly flat. All right, and I happen to know, so I pre-built a couple of the gates, and these are opposing. I can feel the force. Okay, so they're opposing. All right. All right. So there we go. So now we have all 3 of the idlers are built. All 4 of the idlers are built. Let me move those out of the way. Okay. All right. Now let's go to the gates. So the gates are going to have 4 parts all together. You're going to have a magnet that's going to be in the opposite polarity of the idler, and you're going to have 2 of the ECAS PTFE connectors. Okay. So I left this one out so that I can show you how I do the PTFE connectors. I know that probably people are going, Why are you showing us how to do stupid stuff like that? But I just take and the two pieces, the cap, okay, and the connector with the gasket, okay, with the gasket, and I just put it between the rag so that I don't wreck it, and I just squeeze it until I hear it go click. Here, yeah, okay, there it go click. All right, there you go. And then I take this off and that off. Okay, and I don't need that anymore, so in the garbage it goes. All right, and then it's very important that you have a really good press fit of these ECASs, okay? And if you print in ABS, ABS is going to shrink a little bit, about 1%, 1 to 2% when you print. So you should have a really good snug, fit. So the way I do it is I just put it on a flat surface and I literally drive it in until it's flat all the way around. Okay. All right. And the reason that I take off that gasket is because, actually I covered it up now, but on the inside there's actually a 4mm round tunnel where the PTFE is going to butt up against the hole. So you'll have a perfect non-obstructed path for the filament. Because there's nothing worse than when the filament starts to hit flat spots along the path as it makes its way to the tool head. Okay, all right. Then the next thing that we need to do is we need to take a 5mm ball bearing. $5mm ball bearing and two 10mm, I have an extra, two 10mm self-threading screws. It's in the bill of material. And inside, you'll see that there's a little place for this ball bearing to go. And what happens is when the filament goes in, it pushes the bearing up. Pushes the bearing up against this micro switch. Okay, so the switch is going to go towards the same end as the bearing. Okay, so bearing. All right. Now this is how I do it. I'm just telling you how I do it. So the very first thing that I do, since we're not going to be using the center terminal on this switch, I cut it off. All right, I cut it off. Makes it a lot easier all the way around. Then the next thing that I do is I push this switch in as far as I can get it to go, okay? As far as I can get it to go. And then I let the screw bring it up to its, what I want to call it, its lowest spot above that bearing. Because here's what, and I'm speaking from experience, right? That's that ask me how I know statement. And that is that when that switch is activated, it can be activated when the filament first goes in. All right, and then Happy Hare will indicate that we have a good entry point to the MMX. But then, as filament continues on its path through to the tool head, if it isn't perfect, all it has to do is bounce one time and cause a normally open condition, and it's going to cause a failure, even though there's actually filament in and it's all the way to the gate sensor. Okay, so, and then the next thing that you want to do, probably the most obvious thing that you want to do, take a piece of filament and run it through. It's going to be a snug, and that's okay. All right, and you just want to be able to hear Let me see, I'll put it by my microphone. And if you can hear that, you're good. All right. So that means it won't give you a false indication in the filament path. All right. And then with the last magnet that I have here, I have one that's not done yet. Right. So one way you can protect yourself is you can go like that, and now you know that it needs to be. You can just slide it over, and that'll cause it to be in a opposing polarity, right? And you can, before you put it all the way in, just make sure, and you can feel it on the 1050, on the 52s, on the N52s, you can really feel that. But in my opinion, it's better. The reason that I prefer the 52s is because when the gate is not engaged, I want my filament to be able to move freely. Okay, so now you can see it's just hovering. It's hovering above this. All right, so it's working. It's absolutely working. All right. All right, so let's move on to a little bit of hardware here. And we're going to take the idlers and we're going to add the idler gears. Okay? The idler gear. All right. Now the idler gear has 4 parts. There's a spindle, and then there's 2 of these little bearings. Let me see. Spindle, and 2 little bearings. Okay? And you can put it in either way, it doesn't matter. All right? What I'm going to tell you is a little tip. That now is probably a good time to just put a drop of, I use super lube. Okay? Put a drop in there. Just move it around a little bit. And that is a recommendation, right? So other documentation will tell you exactly the same thing. Okay? All right. So the way that this is going to go in here is because this is this groove, right? That groove is the filament path, all right? And we know that the filament path is going to be right there, right? Let's see if I can't get a good shot of that. Okay, there's the filament path, right? Filament path, all right? So we want that to be the same way. So the gear is going to go on the indented side, right? So the gear is going to go on this side, okay? And just make sure that they're even on both sides and just snap it in on both sides. Just snap it in. There you go. Just make sure it moves freely. Okay? All right, I'm going to pause this. I'm going to do the other 3. Okay, so we have all 4 idlers now have the idler gears installed. Okay. All right. Next thing I want to do, and this is just in preparation for final assembly, the easiest way to get your servo into this enclosure is to do it before you do anything else. And the reason for that is because these screws, especially the ones that are behind, when you're in the enclosure, getting to these back screws is really hard to do. Okay? So, and by the way, there was somebody that said to me, hey Rick, you need to put screw lengths in your instructions. So I'm going to do that. I'm going to add the screw lengths to the instructions so that everybody knows what the screw lengths are. So let me find which screws I need. So these ones are going to be, I'll get out my handy dandy screw measurer. And these are going to be M3 by 16. Okay, so M3 by 16s. Let me grab a couple more. I'm just going to do the outside corners first. Drop a nut on there. And because I came prepared, and I'll do one in this outside corner. You know, I'm not going to snug these up yet. I'm just going to make them, you know, whatever you want to call it, finger tight. And then once the belt is installed, and I'm going to show you a little trick on that as well. Okay, so they're all in there, and I can slide this up and down relatively freely, but the screws become kind of an angle. It's probably the most cumbersome part of the entire build. All right. Obviously, I told you that all of the heat set inserts, all the locations are noted in the instructions. So again, I'm not going to bore you with heat inserts. Okay, let's start assembling the gates here. And so what I want you to see are these two heat set inserts right here on the end cap. Okay. These need to be straight. They need to be straight up and down. They need to be very perpendicular to the surface. And the reason for that is because all of these need to line up in a row, straight up and down all the way. Okay. I mean, here's the deal. If the gates require precision printing. So make sure that your printer is tuned, well aligned, and you're happy with your prints. They need to be really substantial. Now, you know, Nadir has designed these so that they are printed with, depending on which parts, 4 to 5 walls, 20 to 40% infill. I print in ABS, and yeah, so it gives me a lot of room to play with. One of the things that I did was I printed these parts on their side. Okay, so there's two ways you can print it. You can either print it standing up, or you can print it on its side. I printed it on its side, and I just put standard, I just used normal supports, and I just peeled them out, okay? But what that did was it gave me a really good surface on this side, right? So I had perfectly flat surfaces on both sides, right? I did the same thing on the dividers and the separators, okay? Actually, the separators I printed standing up like this, but when I got done, as you can see, I just took some emery cloth, laid it flat on a table, and I just sanded these down nice and flat. Okay, you can kind of see the rough areas on there, okay? And then I just kind of test fit everything. I make sure that all the bearings fit into the grooves, right? Make sure that they go in all the way, that there's no part of that bearing and the flange sticking out, okay? So that they're flush. I do that with all of them. So the gates, these bearings can be a really tight fit, okay? So just when you put it on the side, just kind of bend it open just a tad, don't break it, just a little bit, and put it in there, okay? Just like that, all right? Just like that, all right? And I did it for these and this, and where's gate number 4? So I'll do this one. Let me open that up, get that in there. There we go, snaps in there nicely. Okay, so we have 4 gates, 3 dividers. All right, so I'm going to put the threaded rods into those 2 heat set inserts. Okay. And you can see that they're nice and they're square. Okay, all right. So the first thing I'm going to do, you can take any gate because we're just going to define them by the wires that are attached to the sensors. Okay, so these pre-gate sensors are going to be assigned by how they're wired. All right. That should just go right down like that. Should move pretty easily. And then when you get to the end, just all the way to the end. Now, one thing that I found was at the very top of this bearing, you may have to kind of bend it a little bit and make sure that it pops into that groove. And once it pops into that groove, you'll see that that is a beautifully tight fit all along the edge. Okay, it's really important that you have nice, tight-fitting gates. Okay, all right. Because what we don't want to have happen are, especially for the drive gear rod, we don't want to have that bend, right? We want that to be a nice straight fit all the way along, okay? Plus, we don't want to run out of room on these. So I've seen some pictures of folks like on the Discord and stuff, and some of their gates do not, they're not tight and neat, okay? And that could cause a problem, all right? We need to drop this into here. Otherwise, you can't get it in after that. So you got to drop that in there. All right. I'll leave these assembled. And except for this one, pull that one off. Grab another drive gear. Drop it in there like that. Another divider. Now, you know, you go ahead and file. I can see just by looking at this that this probably needs a little bit more room in here for the bearing. So I'm gonna just kind of file that out a little bit. Next gate. So I can see that I just want to clean things up a little bit. Sometimes where the supports are, you know, these little remnants of things. Pretty good. Drop in the drive gear. Next spacer, I'm going to clean this up. And you know, this is just the normal stuff that you would do, right? This isn't because it was printed wrong or anything. These are the things we do no matter what we build. So, gorgeous. Oh yeah, that'll definitely work. I'm not sure that that's quite right. I can see it. I don't know if you can, but it looks like the top, let me see if I can get that focused in there and good enough for you. That is sticking out a little bit right there at the top. So I need to kind of twist it a little bit and get that to pop in. And there you go. This will all be squeezed together at the end. All right, cool. All right, so I'm not going to put this drive gear in yet. Now, here's one I want to show you something. So on this edge right here, do you see there's a protrusion? And one of the problems that I had was it was when it would come down, it would catch on that protrusion. So what I did was I just took a file and I carved a little bit of that out, you know, a millimeter or so. Anyway, I actually designed a new part, and I will put a link to that in the description so you guys can get to that. All right. Okay, so before we put the end cap on, what we're going to do is we're going to start putting our idler arms on. You need to start with gate 0. And so I'm going to start at gate 0, 1, and 2, and lastly 3. And this will fit nice and snugly into this hole on the end. Okay, you see that little, yeah, there we go. So I'm just going to kind of push that in there. And you can see that the opposing magnets they're definitely working. Again, just my preference, a little drop of super lube on the PTFE, and these guys will really stay nice and loose. And but that's just me. Okay, so let's go ahead and put this end cap on. So, all right, so make sure you put your drive gear in, just like that. And we'll put our end cap on. And it's going to act just like the spacer did. And the 3mm rod will go right into that hole. Just like that. Look at that, just like downtown. I love it. All right. All right, and then a couple washers. M3 nuts. Handy nut driver. Don't tighten these down too much. We have a lot of work to do. Okay. I'm going to move this out just a tad so that you can see more of what I'm doing. All right. So now we have all of our opposing magnets, our goods. So some of these are going to really jump around. That super lube is going to kick in and everybody's going to be working really well. But as you can see that when the cam is over the top, right, it's going to keep them open and then it'll engage. It's going to leave a lot of room in between. Lots of room in between. Okay, so in this position right here, and I can feel the force, the opposing force of those magnets. This is going to give me a clean distance between the drive gear and the idler gear so that I can manipulate the filament any way I want to. I'm pulling it out, pushing it in, whatever it is I want to do. All right. All right, so now what we need to do, let's put this right over here. And we're going to make the 80-tooth gear, the T80. The T80. All right, so I'm going to grab my T20. And the T20, the aluminum T20s, this cap, this outside ridge will pop off of the gear. Right? Sometimes you need to use two pairs. See, this comes right off. Yeah, see, comes right off. Okay, there you go. All right. All right. And then what's going to happen is you're going to see all the grooves in here match, plus room for the screws. So the screws are literally just going to thread themselves into these open spots between the gears. Right? So each one is going to have a V between two teeth going around the outside. Okay. All right. And I am going to grab, I'm going to use button head screws for this. Button head screws, they're a little bit more, what's the word I'm looking for? They're a little bit more friendly with the, what is that piece? With the little hub, okay? He calls it the flower, all right? So, and that's going to go over the top, and then the screws are going to thread directly through that, all right? And so I'm going to go with M3 by 10s. So I need 5 of those. M3 by 10, button head, quantity 5. Quantity 5. Okay. And good. All right. And I'm just going to do, you know, one and then one across, you know, as if you were changing the lugs on a tire on your car. It'll thread right in. You don't have to put too much force this way. Okay. And just swing that over, and then I'll do this one over here. A lot of times I'll get comments on my YouTube videos. Hey, what screwdriver did you use? So I'm going to get that out of the way right now. So this one is a Fantic. I don't know the model. This one is a Gren Pro. This one is an electric screwdriver by FCC. Oh, I don't know. I don't know who makes it. Anyway, I like it. It was cheap. It works. Pretty powerful. All right. So nobody needs to ask me what screwdriver I use now. All right. But I'll tell you something. This one here, this Fantic, love it. It's got so much power. I mean, there must be quite a set of planetary gears in there. It's very powerful. The only thing that I wish it had, and I think that there is a model that does, is if it had torque settings. Because I have a tendency to use a little bit too much brute force. Okay, so there we go. So 5 M3 by 10 button head screws. Okay. All right, so that takes care of that. All right. So now what we need to do is take one of these 5mm rods, and this will open up all of the idlers. Hopefully I can get a good shot of this on here. Here I'm going to use. Am I going to use this guy? I'm going to use this guy. Why not? Sure. All right. So this is a M1.5 driver. Okay. And what I'm going to do is I'm going to find on each one of these. So I'm going to start at the end. I'm going to work my way through, and I'm just going to wobble it around until I get through. And what might end up happening is you'll hit one of those set screws like I just did. So I'll have to back off that set screw a little bit. And then it'll go through. Yep, goes through. Go to the next one, kind of wiggle around a little bit. Yep, hit the set screw. Loosen that up. Go to the next one. Wiggle it around a little bit. Okay. Yep, hit the set screw. Loosen that up a little bit. Most of these drive gears, when you take them out from the kit, the grub screw, the set screw, will be at the bottom of the bag. So if you think that you got a gear without a grub screw, just look at the bottom of the plastic bag. It's most likely there, till I get it in there. Now, I've done this both ways, just FYI, where I start with the rod in here as I'm building the gates, and all it did is seem to complicate things. It didn't seem to make anything easier as far as I was concerned. So feel free. I mean, if you think that it'll be a little bit easier for you that way, go crazy. Okay, after wrestling with this for a little bit, I got the rod all the way in. So now what I'm going to do is I want to line up. And so what I'm going to do is I'm going to use a piece of filament, and I'm going to line up the center of those drive gears. Okay, so I'm going to, now that it's centered perfectly, see that? In the teeth of the gear, I will fasten that down right there. Okay, he's not going anywhere. All right, this guy, let me grab that while I can see him. He's right down the middle. I like it. That's beautiful. Okay. Sometimes this is where I think the D-rod might have been an easier proposition. And the reason I say that is because if the grub screw itself is sticking up at all, it can get caught in the channel that it has to move around in. See that? And you can see it's got a little bit of filament in there. See that little bit of filament? Whereas if it's a D-rod, you can tighten it down to basically surface level before you crank it all the way down. All right, so there's that guy. Let's do the last one. And I'm going to grab this grub screw right away. All right. And he is in the center. All right. Love it when a plan comes together. And there you go. I can't really turn this by hand, but I can. It's slippery. And he spins right in there like that. Yeah, I can't quite, but it's pretty free. There we go. Yeah. There we go. Once you get it going. There's probably a little bit of debris in that channel, and it is out now. And I can tell you one other thing I'm going to do. I mean, before I plug this thing in and before I try to spin up the motors, I'm going to take my battery-powered duster, and I'm going to blow the crap out of this thing, okay? Because that's a number one culprit. All right, so now we have our gates are behaving. Almost. Oh, come on. Hey, look at that. All right. Oop, that one's a little bit too good. All right. All right. So now, the next thing that we're going to do is we're going to mount this motor. And just my personal preference is that I am going to mount it connector side down. connector side down, okay? And what I did was, you know, when you get the motors, you get those really long cables. So I just made it shorter, right? So I kept the original motor, end, and then I snipped it off, made it shorter, and then put my own JST connector in there, okay? All right, so it's short enough and manageable enough underneath there, okay? All right, so I'm gonna put this guy like that. All right, there's going to be 3 screws. So one is going to be, let's call it, you know, this is the swivel point. And I'm going to take a wild stab here and say these are 8. Let's see if I'm close. Yeah. Okay, 8 millimeter. So M3 by 8. Okay, that's my anchor point. So that's what's going to allow me to adjust the motor, the belt tension. Okay. All right. The other 2 screws are important that you put washers on them. Okay. So make sure you put washers on them. Makes it hard to adjust otherwise. If you do have to adjust, so make sure you put a washer on there. Now I may have to go with M3 by 10s on these. I've got a feeling. Oh, maybe not. Let's see. Okay. All right. So again, still M3 by 8. Probably the most common M3 screw. I have hundreds of them. So I used to run out of them all the time, and then I saw, you know, a bag of 100 for $6. I said, 2 bags. I'll take 2 bags. So, all right, so I'll just firm it up. Okay. There you go. Yeah. All right. We're getting there. All right. So now the T80, okay, it's going to go on like that, and our T20 is going to go on like this. And I'm going to need, oh, look at that. Hey, bet you this wasn't missing at the bottom of a bag. 2 grub screws in the same hole. Right. Just got to look, right? All right. 2 grub screws in the same hole. That means somebody else down the road is not going to have one in their bag. And on my other one that I have, I just made this just shy of the end of the shaft on the motor. Do this guy on the flat side. All right, so this is the 188 belt, not the 184. So where's my 188? 184, 188. This is my 188 belt. And this is where the adjustment comes in. Let me loosen this up. Okay. And just make it even. Just like that. And since there is no flat spot on this 5mm rod, just make sure it's staying straight. You crank that down pretty good. It's amazing, because of the way the end of a grub screw is, it's a dull point, let's call it, but enough to put a good groove, into the rod. Okay. How did I cut the steel rods? A Dremel with a grinding disc, and I downloaded this thing on Printables. It's just an arm that you screw the Dremel into, and it's on a pivot, and that's all I did. I put the rod in the little groove, and I pivoted it and cut it off. Nothing fancy. It worked just fine, and one of the reasons that I had to do that to begin with was because I decided to get an oversized rod and then just make as many as I needed. All right, so I am not putting a ton of tension on this belt, okay? Just enough so that I know that it's going to catch the teeth, all right? And then I'm going to crank down the pivot, okay? All right. All right, so that's good. That's plenty. If you make it too tight, your stepper is certainly going to complain. Trust me. Ask Nadir. We had to go through that for a little while. All right. Okay, moving on. All right, so now we have the motor and the belt mounted, and now what we're going to do is we're going to put the camshaft on. All right, and I have a little tool. Doesn't look like much, and I'll put the model file in the link. This is what I use to test, all right? Because it'll leave this entire area open at testing time, and it'll still support the cam correctly within this groove. You'll see what I'll show you in a second. Okay. All right. So last rod. Okay, 5mm rod, and where's the cam? There's the cam. All right, so what we need to do is take our our bearing, and press that in over there. All right, pressed in. You can see that? Yeah. Okay, good. All right. And then we're going to put this end through here first, okay? Actually, no, we're not. We're gonna things have changed. There's been some design changes. No, it is definitely going in that way. Yeah, there's been some design changes to the cam, several of them. We've been working really hard. I know that there's been some people that have just been losing their minds because there hasn't been a build video. For that I apologize, but we just want everything to be perfect. So we're going to take the cam, we're going to take the 5mm rod, we're going to put it all the way through, we're going to insert it into the bearing on the end. Pretty simple. That's if I cleaned up the end of the rod good enough. Apparently not. Let's try the other end. I'll clean the other end up later. Okay, yep, goes right in. All right, beautiful. All right, so now, without putting this end cap on, which would have a bearing right up there to hold this centered in place, it'd be kind of tough to adjust the gear and the belt that goes to the cam. All right, so what I did was I just made a little spacer that allows me to take my 184 belt, right, my 184 belt. Before we do that, we need to put the idler pulley to the small bearings, and they are going to be face to face, like that. And they're going to go in the idler, on the pulley idler mount. And it's going to go like that. And then you'll see that it's got a little bit of a lip there. Okay, and that is going to like that. All right, so let me get some screws and make sure that I get you the correct lengths. So this looks like it's going to be looks like a M3 by 18. Let's make sure I didn't lie to you. Yeah, it looks pretty good to me. Yep, 3 by 18. All right. Don't crank this end down too much. Make sure that that pulley moves freely. Okay, there you go. Okay, looks good. Make sure that looks like they line up. Looks good to me. Okay, then you're going to have this. I think this is 36, right? T36, printed in ABS. All right, and I'm just going to put that right onto my servo. Crank that down. 184. It's going to go over the cam, behind the belt idler, and over the servo mount. Okay. This little piece right here, let me put that on first. That would make more sense. This goes right up underneath, right underneath of here. It slides right in place. It's exactly a half of the diameter, or half of the radius of the... Okay, you see what that does right there? Right? So it holds this in place as if it were as if it had the end cap on. Right? So it's as if it had the end cap on with the bearing holding this in place. Okay? So same difference. They're in exactly the same location. I'll make sure I get that to you. And I'll tell you what, a drop of lube wouldn't hurt there. It'll keep it from shifting around. And then we'll put the belt over the idler and around the T36 like that. All right, look at that. So pretty loose, okay, but that's why the servo is adjustable. All right, and again, not too tight, right? It shouldn't sound like a guitar when you pluck it, okay? All right. Good. All right. And when you have it exactly the way that you want it, all you got to do is, because these nuts are so tight up against the servo, you don't need a wrench or anything. You can just take a screwdriver and stick it between the nut and the servo. It'll hold it in place and you can tighten it down. All right. All right, so we're getting there. Look at that. All right. So we have our drive gears. All right. And as long as we're at it. Okay. So I now have gate 1 is fully depressed. Agreed? Gate 1 fully depressed. So if I had auto load, right? Auto load, which it'll sense the filament coming inbound on that switch. As soon as it senses that inbound filament, the drive gear will start. It will grab the filament. And it's going to run into the... Well, we can take care of that real quick. Let's do this. And there we go. Ta-da! All right. And then if I back that off, because I have that nice strong magnet in there, No problem. Okay. I like it. All right. Okay, so so I'm going to suggest at this point that we do something before we do anything else. Okay, so I made this little wiring harness. I made pictures of it. I gave you a wiring diagram for it in the manual that I wrote, okay, which you'll have access to immediately upon release of this video. And so this is going to be the EBB42 side, and this is going to go into the JST connector plus I can't think of this one, okay? All right, so the way that I did it was I just started at one end and I worked this way. So I have a common ground that goes across all four. One common ground that goes across all four, all right? And then I just made longest, long, short, shortest, okay? So I'm going to grab yellow, which was my longest, and I am going to, where's my needle nose? Needle nose, and I am going to connect that to this micro switch on the far side. And those little JST connectors just by themselves really clip on and work really well on these micro switches. So I haven't had any problems where like they fell off or were unreliable or anything like that. So just my suggestion, you can do it any way you want to. If you feel better soldering them on, solder them on. I'm a soldering maniac, so I understand, I get it. I was actually certified a long time ago for soldering. All right, let's go to the end. And like I said, this just makes it a lot easier to troubleshoot, right? So let's just say I got to take one of these gates out because I have a failing micro switch. The bearing isn't in far enough, or it's unreliable. I'm getting erroneous errors. Happy Hare is reporting that I'm missing filament when you can see it in the tube. The reason I'm saying these things is because I've seen these things. We've been working hard to make sure that this is absolutely perfect. I don't know. I'm just happy that they let me play. So, all right, the design is all theirs. I just cause trouble and tell them what's wrong. All right. Okay. So now that I have the wiring harness in there, we're going to put the LEDs in the front. Okay, so the way that I did this is I solder them on the vertical, right? So I solder them with the wires actually literally standing up. So I put a little ball of solder on the land pattern, and then I tin the wire and I solder it standing up. Okay, all right. So hopefully I did it on this one enough. And then we can just slide these guys in. So he's 0. So he's 0. This one might be a problem because I didn't take my own advice on the first LED. I did a traditional soldering job on the first LED. We'll get there. All right. And the second one, see how they would, this is how they're supposed to go in. Gate 2 and gate 3, okay. Unfortunately, this one's going to be a little tough. I'll probably break the wire off doing this. Let's see. I'll put it like that for now. Okay, and then what we would do is you would take the diffuser, right, and it would just go right on the front, just like that, and then it'll cover up the LED and hold it in place, just like that, just like that. See that? Thing of beauty. Okay, and then same thing with the next one, and the next one. And see, they just get held right in place. See that? Right, because there's a little curve in the little concave portion of that. So I'm probably not going to be able to do this one. I'm going to have to resolder that. Yeah, I'm going to have to resolder that. Okay. All right. So let's go ahead and put our EBB board on. Yeah, first things first. Let me get this PTFE out of here. Okay. Okay. So this is a little board carrier. Okay. And there is a right way and a wrong way to mount this. All right. So what you'll see is on the bottom is that there is a partial hole. Okay. Goes down a couple millimeters. And then there's a wide section. It goes like that. So there's going to be 3 screws that are going to hold the board tight, and one that's going to go through the board, through the carrier, and into the bottom cover. That way it doesn't move in and out. Okay, so let's do that right now. So this is easy to pick these screws. So I got a couple 4 millimeters here. 1, 2, 3, 4 4 millimeter. And I believe that these are going to be like probably go with an 8. All right. So it comes in from the side, right? So CAN or USB come in from the side. All right. So I'm going to mount it like thusly. I'm going to mount it thusly. So maybe this won't be an 8. Maybe this will be more of a, no, this probably be all right. Okay, good. So this is an 8. All right, and then it slides in. I turn down this screw, and that screw will hold it in place. Oh, I need to put it in all the way, don't I? That'll hold it in place. Doesn't go anywhere. Okay. All right. So that's why I put all the guts in, because we're going to put the bottom on. All right. Bottom is going to go like this. And for now, I'm just going to put a couple screws in because we're going to take a look at a couple things. There he is. Come on. My bad. Okay. So there we go. I mean, we have an assembled MMX, a fully assembled MMX. Okay, and I'm not going to go through the wiring because there's pictures and diagrams and literally pictures in the manual. And there's only a few things that need to connect, right? And guess what mistake I made, and that's why I wanted to do it the way I did, and that is the motor cable, right? So the motor cable should have gone underneath and then plugged into the board, all right? You know, it might not be a bad idea either, just as a suggestion. You know, they're like, I don't know, like $2 on AliExpress. A heat sink for the motor. Stepper motors run hot. Also, and I'm going to talk about this in the intro, right? So I'm filming this, and then I'm going to film the intro for the video. And one of the things that I'm going to talk about is an external power supply for the servo. So the servo is not driven. It's 2.5 amps off of this EBB42. It can be a little stressful, okay? Also that you can use an external 24-volt power supply and still use USB, right? Or use 24 volts off of the main board, or add a 2596 buck converter 24 and crank it down to 5 volts, 5.5 volts to drive the servo. There's all kinds of possibilities here. So you know, I'm going to talk about that. All right. Very well done. Congratulations, Nadir. Job well done. I'm happy with mine. Now we got everything working, and we're working on some stuff. Blobifier. Probably by the time this video gets released, Blobifier will be done, and we'll have a whole multi-material solution. So we'll be able to purge better and faster than bamboo. We'll be able to color change better and faster than bamboo. And there's some reasons for that, okay? So this is a type A. This is a type A MMU. The others that have independent motors to drive each individual gate is a type B. And I'm going to talk about that. Actually, once I get done with this video, I'm going to do a video on just about every kind of MMU that exists in open source today. There will be a video Antonio from Core 3D. He's been tremendously helpful in code Hare and Blobifier. So he's going to be putting together documentation and a video for both Blobifier and Hare. And I'm sure I'll be talking about this in the intro, but remember that now Hare, through the installation utility, has an option for MMX with EBB42. Okay, so no fuss, no muss. It's an easy configuration. I'll talk about filament management, all that stuff. So hopefully this was worth the wait. I appreciate you guys taking the time. Like I always say, if you like what I had to offer, make sure you hit the like, subscribe, and alert bell before you go. And I appreciate you sticking with me through the entire video. Have a wonderful day.